Bismillahirrahmanirrahim. Let's start with this new topic uh, of union, intersection, and complements of FAs. But before have a discussion on union and intersection, first we want to discuss something about the complements of FAs. And if we want to apply the complement operation over a single FA, keep this thing in your mind, over a single FA, then what you have to do, the first step is that you have to convert your FA into DFA. DFA means that you have to complete the outer degree of all states of the FA completely according to the input symbols. And then the second operation that you have to perform is you have to convert the final states into non-final states, which means that if in your FA you have mentioned some final states, you have to remove that status of final states in that FA, and you have to make those states as a normal state in an FA. That's why it's called non-final states. And point number 3 is that you have to convert your non-final states to final states, which is the reciprocal of step number 2. Which means that the normal states which exist in your FA, you have to convert those normal states into final states. We will have this complete understanding when we will see some example over it. For example, as you are seeing this FA on your screen, and this is the initial state represented with minus sign, and this is the final state of this FA represented with the plus sign. From the initial state, we can take an A and we can go to the final states, and then from final state, after taking B, we can again reach up to the initial state. And similarly, there is a loop with B on the initial state, and there is a loop with A on the final state. So this is basically the FA you have that you have to convert, on which you have to apply the operation of complement. So now I have to apply these 3 steps that you are seeing, and I am highlighting these 3 steps with the cursor. So now, first you have to check that either the output degree of the FA is complete or not. If it is complete, then it means that your FA is already a DFA. So for example, I can see that there are 2 input symbols, and this is one edge and this is another edge. So 2 output degree is complete. And on this state, this is one edge and this is another edge. So 2 output degree with A and B is complete. So this is basically a DFA, and I don't have to convert this FA into DFA because it is already in a DFA. So now only 2 steps are remaining: conversion of final states to non-final states, and the other step is conversion of non-final states to final states. So this is my my non-final states. So I have to convert. Okay, first apply the step number 2, final states to non-final. So this is my final state, which is plus. So I have to remove this plus here, and I will get something like this here. So now this state is not a final state anymore in this conclusive FA that we want to draw. And this is basically the non-final state. So now I have to apply the step number 3. And so this is my initial state, and which is a non-final state. So I have to make this state as a final state. So I am applying this plus symbol here. With this plus symbol, what I am drawing or designing in this FA, that I am now mentioning this state as a final state. And previously it was initial state, previously it was non-final states. So I don't have to remove that status, which is initial state. So I have to keep that status of initial state as it is, but I have to put plus symbol here. So now this is my initial state and this is also my final states. So, and now my three steps are complete, and this is the complement of this FA. So this FA is doing what? This FA is accepting strings having A at the end, you can say. It can start with B, and then if there is an A at the end, then it will be accepted. So this FA is for those languages in which the string contains A as a substring at the end. Now look over this. This FA should be something opposite to this FA, then only I can say that it is a complement of that FA. So now this state is accepting B at the end, and it is the initial state. So A, it can take A and then A loop and then B if there is a B. So now this FA is accepting strings having B at the end of a substring, which is a opposite to this FA. So this is called complement. So this is called complement. Let's have a look on another example. This example is ended here because it is mentioned here with this line. So now there is another example. I can give you some theoretical statement, then you have to draw your FAs first, and then you have to apply the complement, union or intersection accordingly. For example, the language given to us is words start with A. So this is the language in which the language have a strings starting with A. And then what is the complement? Theoretical complement. It should be the opposite of this one. Words start with A. So the complement of this language would be words do not start with the A. So this is my theoretical statement, theoretical complement of this language L. But now I have to draw its respective DFAs. So its DFAs can be, now you can see here, or just wait, I can draw these things over this whiteboard here, because I am capturing this video from the office and I have this whiteboard available, bigger whiteboard available here. So we can do this thing here. So what I can do, so let's do this example on that bigger whiteboard for a better understanding. So now what is my language? My language is words start with A. And now what is the complement of this language? So I am asking this question very much theoretically. What is the complement? Complement is the opposite of this language. So what is the opposite? Words start with A, words do not start with A. So this is something, complement is represented with this one, bar over it, and you can write words do not start with A. So this is basically the theoretical statement as a complement of this language L. And now I have to draw the FA of this language, and then I will convert that FA into the complement form of this language. So now I have to draw the FA. So word starts with A. So this is my initial state. This is my initial state. And then I have word starts with A. And I have another state, and I can make a loop here, and then A comma B, all combinations of A and B. But it is starting with A. Starting with A, and then have any combination. So this is the FA. But if I have to make this FA as a DFA, then I have to complete its other edge also, and other edge is B because there are two input symbols. So I have to draw another state, and furthermore, this is the final state now because words start with A and any combination. And here, if it starts with B, then it means that it is something not belongs to the language. So it should be within that FA, and it must not reach to the final state. So that's why I have to draw another state, and that is called rejection state. And then you can make a loop there, A, comma, B. So this is my rejection state. So whenever a string which is illegal string of that language, that string will go here and it will end up here without reaching at this final state. So this is the proper DFA of this language. Now, what I have to do, now I have to convert this DFA into its complement form, and I have two steps. The first step is the conversion of final states into non-final states, and the other step is the conversion of non-final states to final states. So now, this is DFA, this is the first step already on the whiteboard. And second step is conversion of final states to non-final. So I can convert these final states into non-final states. This is my step number 2. And step number 3, is there any other final states? No. So this is only one which I have converted to normal state. And what is the step number 3? Conversion of non-final states into final states. So this is my non-final state. This is my non-final state. So I have to make it final state. I don't know. Maybe it is okay or not. I don't know. And this is also a non-final state. So I have to convert this non-final state into final state. Okay. So now we can see either it is recording. So words do not start with A. So this is my initial state. This is my initial state and this is my final state. So this words do not start with A. This language can accept null strings, which is according to this one. Words do not start with A. Null string is not starting with A. So this can be accepted here. And the strings do not start with A. So if it starts with B, I am reaching here and then any combination. So this is exactly the opposite of my previous case when it was starting with A and then any combination of. So this is now the complement of this language. That's good. So now you have seen that how can we apply the complement operation. So now I am again pausing this recording and coming onto the other screen. So let's have a look over this example now. Now you can see that this was my first version, DFA. Words do not start with A, and then we have words do not start with A. The first one is word starts with A, and this is the language words do not start with A. Okay, that's fine. Now you have seen on the board, and I think you have a better understanding. Now there is another example, this one. The language is L is equal to AB. The language is have only one string, that is AB. So now I have to draw its FA. You can see its starting states A and then B. So this is AB. String AB is going to be accepted here, and all other states are all other edges are reaching at this rejection state. So if B will come, I will reach here. A will come, I will reach here. And any combination of A and B, it will reach here. And this state has its two edges in this loop. So this is now the DFA for this language. And now you can convert into its complement form easily uh, by using the knowledge that you have obtained here in 3 steps, 1, 2, and 3. So you can now apply these 3 steps over this TFA easily. Rather, 3 steps you have to apply only 2 operations because the first operation is already applied, and this is the DFA. So now you have to convert the final states into non-final states and non-final states into final states, and then this will be ended. So do it by yourself. Now this is another example for you for your homework. If you have a language like this, language has a substring A, B in words. So it means that you have the language and you have the strings of that language, and those strings can be any containing A and B, but there should be some fixed pattern AB as you are seeing on this screen. This AB I am highlighting. So this AB should be the part of that string. And you can have something in the beginning, at the end, or in between, but AB must be the part of that string. And if it is the situation, then this is the language. And for that one, you have a FA like this, initial state A and then B. So B can be in the beginning, and if it is A, then after it will take B, so AB, and if A loop and all combination of B. This is quite easy. You can understand by putting some intention over this example. So now this is the DFA. Now you have to apply the complement operation over it by yourself, which is quite easily. Now we can move on to the proper uh, detail of this topic, which is union, intersection, and complement. So you have covered this one, complement, but you don't know anything about the union and intersection, which we are going to cover now. So before this case, we were discussing only one FA. But now if we have more than one FA given in the problem or given as in the question statement, if you are given with more than one FAs, then still you can apply the union, intersection, and the complement operation. Basically, union and intersection needs more than one FA. So that's why I didn't start this lecture with the union and intersection. I started my lecture with the complement because the complement operation can be performed on a single FA. Not on a single FA, it can also apply on more than one FAs, but now you will see how you can apply this complement operation over more than one FA. Union and intersection is always for more than FA because you have to combine something, and or you have to take something common between two things, which is called intersection. So union and intersection is for more than one FA. Complement is something which can be applied on a single FA or more than one FAs. But there is some procedure, and after that you can apply this complement operation in case of more than FAs. So, and we will see that procedure here. So for example, if we have a language L1 as A comma AB, so this is these are the two strings in language 1, and we have a language L2 which has a string AB. So now we have two languages, it means now we have two FAs. So now we can see something theoretically here. If we will take a union of these two languages, union means if you have these two sets, this one and that one, you have to take all the elements of this set and all the elements of this set, and you have to put all these elements in another set. That set is called the union. Very much same concept as you have already studied in mathematics in sets. So union means there would be some set you can see on the screen. I am highlighting with the cursor. So A and AB, AB, this is again AB. So union would be some language L and I am representing it with U, and it will contain A comma AB, both the strings. This A and this AB here and AB here, so we can keep only one, which is the representation of those, both of these substrings AB. So this is basically the union of L1 and L2. It doesn't mean that these are the elements of only language L1. This AB is also the element of L2. So that's why we are also considering A comma AB. That's why we are also considering the union of these two sets are two languages, you can say, just like very much similar to your mathematical concepts that you have studied in your previous classes. So this is basically L1 union L2. And if we want to take intersection, then normally in mathematics you take only the common things. And what is a common thing in this language and that language? This is AB. So AB is common. So intersection would be AB, and we can represent it with L1 intersection L2. So this is also simple, but this is theoretical. When it will come into the form of these designs like that, then you will see. You will see. You have to design the FA which can accept the string as a union, or which can accept the strings as an intersection of two languages are like that. We will see this thing. And the third one is the complement. So complement, this is something, so complement of two languages, L1 and L2, is always L1 minus L2. As you can see on the screen, I am highlighting. L1 minus L2, this is the definition of the complement if you have more than one FAs. If you have two FAs, you can say. So L1 minus L2 is basically the complement of that language. So this is one set and this is L2. So subtract these elements from this set, what you will left over with only A. So this is something, the complement. This is something, the complement now. Okay. Now, this is something you have mentioned for your guidance as a theoretical expressions. But now we have to also draw these machines. We also, because L1 has some machine, L2 has some machine, and these union intersection complement, they also have some machines. So now we have to solve this problem in terms of drawings with the FAs. So for L1, so this is for L1. So now we are going to draw the DFA for this language. L1 is equal to A comma B. So it means it can accept strings as only A or AB. So this is the initial state represented with Q0. So if I will take A, then I will reach at the acceptance states, which is Q1. And if I will read A and B, I will again reach at some final state, which is Q2. And all other options will go into this rejection state, which is Q3. B is coming here, A is coming here, or A, B, and then the loop. So this is the DFA for L1. This is the DFA for L1. Now the DFA for L2. Okay. L2 is A and B. This is the string A and B. So now AB string I have to, this DFA for L2 should only accept the substring AB. So from the initial state, A is coming, and then if B will come, I will reach at the acceptance state, and this AB will be accepted. There is only one string for this language, and all other combinations of this string will go into this rejection state, which is K3. So you can see all these combinations coming here. And now you have the two DFAs, one for L1 and other for this L2. This one is for L2. And now we can apply this union, intersection, and complement operation. But if you want, now what is the steps involved? You have to draw the DFAs first. And if you want to calculate the union, intersection, or complement, what you have to do, you have to design a transition table of both of these DFAs in combination. In combination. For how we can do that, take the initial state of this DFA, which is for L1, so the initial state is Q0, and take the initial state of this DFA, which is the DFA for language L2, and the label for this initial state is Q0. So there is a one column for states, one column for input symbols, and the other column for resulting states. So here, maybe there is a noise of this generator outside, which is recording. So what I can do, I can take a pause and I will come again. So now let's have a look over this. So you are taking these initial states Q0 from the first DFA and K0 from the second DFA. This is K0 and this is Q0. So you are mentioning this Q0, K0, and now you have to consider what are the alphabets A and B, two inputs. So if there would be A on these two states Q0 and K0, so first you have to look this A over Q0. So here at Q0, when I will take A, where I will reach at Q1. So you have to mention Q1 here in the resulting states. And when there would be A on K0 in the second DFA, this is K0, and when I will take A, I will reach where? K1. So I have to write K1 here as a pair in this resulting states, because you are now going to apply the union, intersection, and the complement operation over this one. So you have to combine these two FAs. So that's why it is in the form of a pair. So after applying A over Q0, K0, where I will reach at either Q1 or K1, but you have to write this in the form of a pair. And then on Q0, K0, if I will have a B as an input symbol, then where I will reach? Here I will reach by taking this B at K3, and here I will reach at Q3 by taking this B. So Q3 and K3 are my resulting states. So after writing it, now what are the new states coming into this column of resulting states? This Q1, K1, Q3, K3 is something new. So now you have to take this Q1 and K1 here in the first column. So now you have to write Q1, K1, and then you have to check A and B over these two states, Q1 and K1. So after taking A on Q1, where I will reach? After taking A on Q1, where I will reach at Q3. And similarly at K1, after taking A on K1, I will reach at K3. So Q1, K1, and after applying over A, where I will reach? Q3, K3. And similarly, when you will apply B over Q1 and K1 in these two DFAs, at Q1, after applying B, I will reach Q2, and at K1, after applying B, I will reach K2. So Q2, K2 is the new state here. So, okay, Q1, K1 is something finished. And now what is the new state? Q3, K3. So you have to mention this Q3, K3 here. You have to take all these new states in this resulting state, but you don't have to repeat these states. So Q3, K3, we don't have considered this Q3, K3 here in this column. So now we are going to write this Q3 and K3, and we are going to check A and B over it. So after having A on Q3, where I will reach, this is Q3. After having A, I will reach Q3. On K3, after A and B both, I will reach K3. So Q3, K3, and after applying A, where I will reach Q3, K3. And when over Q3, K3, now I have to check B over it, which is again Q3, K3. So Q3, K3 is now finished. And what is something new? So this is Q3, K3. I don't have to repeat. So Q2, K2 is something I didn't consider here in this column already. So I have to mention this Q2, K2 here now, and I have to check A and B over this state Q2, K2. So Q2, K2, this is Q2, and after having A, I will reach Q3. And this is K2, after having A, I will reach Q3. So Q2, K2, and after applying A, I will reach Q3, K3, and same is the case for B because there is a pair in those DFAs. So this Q3, K3, I have already covered here. Q3, K3, all these Q3, K3s are already covered here. So I don't have, there is no any new pair left, which I have to consider here in this first column. So now this transition table is something finished. And now I can draw my union, intersection, and complement by using this transition table. So now I have this transition table. Now considering this transition table, I have these new states and I have these resulting states and input symbols. So I have to draw a DFA by using these states of these transition tables. So what I can do now, uh, this is just a, what I can do now, first look over this. So in the transition table, I have this Q0 and K0. So I have to draw this Q0 and K0 as a state. And then I have to draw Q1, K1, Q3, K3, Q2, K2. So from Q0, K0, after taking A, where I will reach Q1, K1. So on Q0, K0, after taking A, where I will reach Q1, K1. So you have to draw a new state Q1, K1. Leave it. This double circle is mentioned as a final state, but leave it at the moment. So this is something Q1, K1. And then Q0, K0 after applying B, where I will reach Q3, K3. So after applying B, where I will reach Q3, K3. This is something you have to draw by looking over that transition table. And then Q1, K1, A, where you will reach Q3, K3. So Q1, K1, A. Q1, K1, and after having A, where I will reach Q3, K3. So this is the edge that you have to draw. And then Q1, K1, and with B, where I will reach Q2, K2. So Q1, K1, and if I have a B, where I will reach Q2, K2. Okay, you have to draw this. And Q3, K3, A, Q3, K3, and Q3, K3, B, again the same state. So I have to draw a loop, it means, of A and B. So Q3, K3. So I have to draw a loop with A and B. So now Q2, K2, and A, I will reach Q3, K3. Q2, K2, B, I will reach Q3, K3, same states. So I have to draw an edge with A and B from Q to K2. So Q to K2, I have to draw an edge with A and B. So now this DFA according to that transition table is complete. And then now revise your definitions for the union, intersection, and complement. Union is what? So union is the, if you have two languages, L1 and L2, and if you want to apply the union, then what is the general concept that all the strings of L1 and all the strings of L2. So what you can do, you can just simply uh, uh, keep the final states of L1 and also the final states of this L2 as it is. So you don't have to change the status of the final states in drawing. If your final states of L1 and L2 will remain their status in this final DFA, which I have drawn here on the screen and I am highlighting here. So if L1 and L2 will remain their status of final states, then it means that all the strings of FA will be accepted for L1 and all the strings of L2 will be accepted by the same FA. So that's why it is written here, final states of L1 are L2. So in union, you have to keep final states of L1 or L2. You both have to consider these things. That's why. So what are the final states? What are the final states? Here the final state is K2 of L2. Here the final states of Q1, Q2 are the final states. So in your final drawings, you have to look that where these final states Q1, Q2 and K2 are coming here in this final diagram. So Q1 is the final state, Q2 is the final state, K2 is the final state. So that's why Q1 is coming in this pair, so you have to draw the double circle. Q2 is the final state, so it means this is also a final state, so that's why you have to draw the double circle. And these both, is there any Q1, K1, Q1, K1 or K2? There is no Q1, K1 or K2 here in these states. That's why these states cannot be mentioned as final states. So only these two states are the final states for the union of L1 and L2. So that's why I mentioned here with this bracket, and I mentioned it with you that these both states are considered in the union. And now for intersection. So there is an OR for the union, and you have to remove this OR, and it is an AND for the languages. So if you have two DFAs for L1 and L2, concatenation is that string is coming from the L1 and going through the L2, and then it is a common string of L1 and L2, so that's why it will uh, reach at the end. And here, according to theoretical statements, you have to consider final states of L1 and L2 compulsory. So now, but in this drawing, so what are the final states? Q1, what are the final states? Here K2 and here Q1 and Q2. So this is an AND between these states. So final states of L1 and final states of L2 both are considered. Let's have a look over this. I will explain also. So for example, you can consider how you can do this easily using mathematics. For the case of, I am again going back to union. So for the case of union, so I have to write it L1 union L2 is the set of final states. What is this? What is the final states of L1? This Q1 and Q2. And what is the final state of L2? This K2. And I have to take the union. So that's why I have to consider union is Q1, Q2 or Q3. So I have to consider all these three states. That's why Q1 is here, Q2 is here. So these both are, or you can say K2 is here, which is the final states of the L2. So you have to apply the double circle here as and represent it with the final states. So this is quite easy. But for intersection L1 and intersection L2, the set is, this is Q1 and Q2 is the final states of L1, and intersection final states of L2 is K2. And if I apply the intersection, what are the combinations that I will have? Q1, K2, and then Q2, K2. Q1, K2. You can just multiply and then you have the pairs. You can apply the same concept here. Q1, K2, Q2, K2. So Q1, K2, Q1, K2, Q1, K2 is not a state here. Uh, but this is the union, so you have to consider these states individually rather than in the form of a pair. So that's why either state, Q1 is coming here, Q2 is coming here, so you don't have to check the pair. But in intersection, so Q1 K2 and Q2 K2, because you have to consider uh, the final states of both L1 and L2. So Q1 K2 is one pair, Q2 K2 is another pair. So Q1 K2 is existing here, Q1 K2 is not existing here, but Q2 K2 is Q2 K2 is existing here in this drawing, which is mentioned here, and you can just uh, double circle is already there. If it is not, then you have to draw the double circle there. And I mentioned that Q2 K2 is the only state which you can represent as a final state in case of intersection. Here I is for intersection. Now for complement, we know complement of L1 and L2 is L1 minus L2, and the sets is L1 has these. Now you have a look over this definition, theoretical definition. It will be helpful for you. So in complement, from the drawings, you have to consider final states of L1, final states of L1, and non-final states of L2. Then you will have the complement. So final states of first language and the non-final states of second language. Then you have the complement. Let's have a look over it. So the sets is this one. Final states of L1 are Q1 and Q2 according to this diagram. Q1 and Q2 are the final states, and non-final states of this Q0, K0, K1, K3. This is final, so I will not consider this one. I will consider these three one Q0, K1, and K3. So Q0, K1, and K3. And now you have to check Q1, K0 is existing. Q1, K0 is not existing. Q1 K1 is existing, Q1 K1 is existing here, so you have to draw the double circle here. Q1 K3 is existing, not here. Q2 K0 is existing, not here. Q2 K1 is existing, not here. Q2 K3 is existing, not here. So only Q1 K1 is existing here in this diagram, according to the combinations available here, and then you can apply the double circle here, and then you can represent it with this bracket. And this state is only the final state in the DFA of the complement of two languages L1 and L2. Okay, this is the end. And now it is mentioned here that there is an example in the book in the same topic. And the book is John C. Martin, Chapter 3, third edition. So you have to see that example from the book by yourself. It is already solved there. You have to read it and you have to consider that example also. And now you have this first assignment in Chapter 3. When you will go at the end of the chapter 3, then there is an exercise there and you have to solve these problems 3.1, 3.9, 17, 3.19, 20, 21. You have to solve these problems and then you have to submit your first assignment. And this assignment will give you the credit for your midterm exam also. So I will think over it and I will let you know that what you have to do with these assignments. I will have a discussion with you all people in the class, and then we will decide. But for the moment, you have to exercise these problems by yourself. Okay, up to that time, okay. Okay, Ji. Maybe there is some light here, and maybe you will not be able to see this content. That's why I will speak this a little bit loudly so that you can understand what this is written as. So here we are going to do a practice again for the union, intersection, and complement of two FAs, and two languages will be given to us, and then we have to draw their respective FAs, and then we have to draw the transition table. And by using that transition table, we have to draw the combined DFA again, and finally we have to conclude the union states and intersection states, and similarly the final state, complement of that combined DFA. So this is one language, and that language is saying that X belongs to A comma B spleen star, which means the combinations X is a string, so strings with all combinations of A and B, but there is a condition that A double A is not a substring in X. So AA as a double A as a substring would not be the part of X, and then all strings are accepted. So language 2 is that X belongs to A comma B clean star such that X ends with AB. So all combination of A and B strings having all combinations of A and B, but the string would end with this AB. AB must be at the end of each string. So we have to draw the DFAs first, and this is something I already drawn so that I will quickly go on to the actual things. So if these two languages are given to you, then the first step is that you have to draw these DFAs by using your logic. So this is for L1, this is for L1, and this is for L2. So now I have these DFAs, and now after drawing it, now I have to draw this transition table. So now you can see that this is the initial state, and these are the two final states here, and this is the initial state, and this is the final state here in this FA. So now I have to start it. So the initial state is A, and then the final state is B. Initial state of this FA is B. So this is my first pair of initial states for the design of this transition tables. So at AP, I have to check what are the input symbols A and B. So I have to write A, and then maybe this marker is not giving me the support. So let's have it. So A, B, and then I have to write A, and then A, B, I have to check this also for B. So now you have to check A with A. So at A state, I have this A going on towards this state B. So what I can write this B here. And similarly, okay. So my initial state here is A, and the initial state here is B. So this is the pair from which I can start. And the input symbols are A, and input symbols are B. Yeah. So now at A, after taking A, I am going toward this state B, and at P, after taking A, I am going towards Q. So BQ is the new pair. So A and A. So where I am reaching B, and then from P and taking A, where I am reaching Q. So this is the new pair which will come here. And then AB and then B. So at A, B is on A. And at P, B is on P. So this is the new state. And now you can start. This is the new pair which is coming here. So now I'm going to consider it. So now BQ and then BQ 2 times because there are 2 inputs. So at B, A, so B and taking A, where I will reach at C, so you can write C here. At Q and taking A, at Q and taking A, where you will reach at Q, so you can write this Q here. And at B with B, at state B with B, B is going back to this state A, so you can write A. And at Q state, and B, Q state and B is coming here at this R. So you can write this as a R. So now this is finished. For example, okay. And now this is the new pair. So now I'm going to consider this one, AP. AP is already considered here. So this is finished. This AP is already considered here, so I will not consider it. So I will not consider it. Now CQ. So maybe I will start from this CQ. So CQ is not existing here. So CQ is the new pair that I have to check with A and B. So at C, taking A, B, I am again reaching at C. So C, A, I will reach at C. Q, A, so Q and then A, I am going to this Q. And similarly, at C, B, so C, and then Q, B, Q, and then B, I will reach at R. So you can write R here. Now this is complete. So after which AR. AR is not existing here, so that this is now finished. So this is now AR, so I have to now continue with this AR. Now I have to continue this with AR. So AR with A and AR with B. So A. So at A, taking A, I will reach at B. R, A. This is R, and taking A, I will reach at Q. A, B. A and B, there is a loop. So I am reaching at A, R, B. This is R and B is going to that B. So this is B. And now this is finished. So AR is finished. So you can just cross it, and CQ is now the new pair. CQ is already there, so I don't have to consider it. This CR is now. So CR, now I have to consider this CR. CR is not available here. So what I have to do, I have to write this CR here, and I have to check it with A and B. Now this C with A, this C with A, I am reaching at C. R with A, this is R, and with A I am reaching at Q. So I have to write Q. C with B, so this is C with B, I am reaching at C. R with B, this is R and B is, I am reaching at P. So I have to write P here. So this CR is finished now. And BQ is the new pair. BQ is already available there. So it is I don't have to check. AP is the new pair. AP is available there, so I don't have to check. CQ is the new pair, so CQ is available there, so I don't have to check. CP is the new pair, so CP is available there, no, so I have to check this CP with A and CP with B. So C with A, I am reaching at C. P with A, I am reaching at Q. C with B, I am reaching at C, or B with B. B with B, I am reaching at B. Now check this. So this is now finished, CP. I have to check CQ. CQ is available, so I don't have to check. And now CP, oh sorry, yes. So CP is available here. Now this one, this CP. So this is available there, so I don't have to check, and all the pairs are now finished, and no any new pair is coming into this column result. So which means that the transition table is now finished. So now I can draw the final combined DFA from this transition table. So from AP, so AP is the state. So AP is a state, and from this AP, by taking A, from this AP, by taking A, I am reaching at BQ. So I can draw BQ here. So by taking A, so this is the A. And AP, by taking B, I am reaching at AP. So this is the loop of with B. Now BQ and A. BQ is this one. BQ and taking A, I am reaching at CQ. So CQ. So CQ is the new state, and BQ taking A. So this is the H. BQ taking A, I am reaching at CQ, and BQ taking B. BQ taking B, I am reaching at AR. So this might be, for example, AR. BQ taking B. So this is my B, and I am reaching at AR. So I am finishing up to this point. Now at CQ taking A, CQ is this one. CQ taking A, I am reaching at CQ. So there is a loop here with A. And CQ taking B. CQ, maybe you are not watching the whole story. So just have a look. So BQ taking A, I am reaching at CQ. BQ taking B, I am reaching at CAR. CQ taking A, I am reaching at CQ. CQ, this one with this loop. CQ taking B. CQ taking B, reaching at CR. CR is not available. So what? CQ taking B. So this is now my CR, and this is taking B. This one. Now AR taking A. This is AR. Taking A, I am reaching at BQ. This one. So AR taking A. AR taking A, reaching BQ. AR taking B. AR taking B, reaching AP. So maybe this edge. Taking B. And then CR taking A. This is CR taking A, CQ. Taking A, CQ. So this is this edge. Taking A, CQ. CR taking B, reaching CP. CP is where? CP is not available, so I have to draw a new state. CP. So CR taking B at CP from CR. CR taking A. This is CR taking A, reaching CQ. CR taking B, reaching CP. This one. CR taking B, CP. CP taking A, CQ. CP taking A,
CQ, and CP taking B, CP, CP taking B, CP. Now this is finished according to all these transitions. Now this is the combined DFA. Now this is the combined DFA. And now what I have to do? What are the steps? What are the steps leading behind? The steps of showing the union, intersection, and complement in this drawing. You can also draw these union, intersection, and complement separately. For example, I can show the union in this diagram, and then I will repeat this diagram, and then I can show the intersection in another diagram, and then I will repeat this diagram, and I will show finally the complement in the third combined DFA diagram. So I can do these things. So now, but this is the combined DFA, but it is not showing union, intersection, and complement. So now, what I can do? So union is the definition you already see. Union is the all final states of L1 and L2. So final states are A, B, final states of L1 and final states of L2. So A, B, and this R. So I have to consider this. A is available here, so I have to draw this as a final state. A, B, R. B is available there, so this is final state. A, B, R. So this is R available there, so this is the final state. A, B, R. So no, so A is available there, so this is the final state. So I have now shown all the final states of L1 and L2 in this combined DFA, and this is the union, and this is the union of L1 union L2. So this is the union of this combined DFA will accept all the string which is the union of these two languages. And for example, if I have to show this is the union, so now I can finish it up. And now because now we can work for the intersection, we can show something, the same diagram for the intersection. So intersection is what? Intersection is the final states of L1 and L2. Final states of L1 and L2. So I have to find the pair here in which both are the final states. For example, final states A, B, and R. So these are the pairs. These are the pairs. So I have to check A, B, and R. So this is the final state, but this is not. So leave it. This is the final state. This is not. Leave it. A, B, and R. A, B, and R. This both are non-final. This is the final state, but this is not. This is the check it. Final state, non-final states. This is the final state of L1, and this is the final state of L2. So in concatenation, we can say this is the only final state of L1 concatenation L2. I hope that you will understand. So in pair, in all the pairs, what you have to search in all these pairs that both of these two states should be the final states. And I have found only one pair in which A is a final state of L1 and R is the final state of L2. A is the final state of this one, R is the final state of. So this is something illegal state for the concatenation of L1 and L2. And in this way, you can apply the uh, complement operation over this example by yourself, and I will leave this for your exercise. So up to that, uh, I think up to that point or up to that time, you can say, I can only say goodbye. So goodbye and see you in the next class.